Students, lesson 58, Saxon Algebra 2. If you're in the right place and I'm in the right place, then let's do it, because this is a favorite lesson of mine. It's more on completing the square, and what's fun about it, well, I mean fun, that's a relative word, is that we're going to make it a little bit harder. Let me show you the problem, then you'll see what the drama is. What in the world is this? It's a lead coefficient on our x squared term. We're used to having, it's a 1 normally, but it's an invisible one. We're used to just seeing that, right? We don't want to have a number in front. What in the world are we going to do with that beast? Well, it's not hard at all. What we're going to do is add one step to the beginning of our completing the square calculation. And that first step is to divide away the a coefficient. And what I mean by the a coefficient is, remember in standard form, we call this ax squared plus bx plus c equals 0. That's the standard form of a quadratic equation. This is the drama king right there. So we're going to divide that away. That's what I mean by the a coefficient. So let me rewrite our example. 4x squared plus 3x minus 3 equals 0. So the very first thing we're going to do before we start our regular series of steps for completing the square is we're going to divide that away. So divide every term by 4 on both sides of the equation. Now let's simplify. This cancels. X squared plus, okay, and then here's where the drama comes in. Now we have a fraction for our b coefficient, and we have a fraction for our c coefficient, right? There's the b, there's the c. And on the other side, changing thing. Okay, now we just complete the square as usual. So, step 1, kick to the curb. X squared plus 3/4 x, leave the gap, and this becomes a positive 3/4, doesn't it? Step 2, magic number. We take our b coefficient and we multiply it, but normally we say divide by 2, but multiplying by 1/2 makes a lot more sense. Coefficient is a fraction, so we'll use that as an interchangeable way to adjust that, and then we're going to square what we have. So this will become 3/8 squared, and that's equal to what? 9/64. Ooh, that's pretty exciting, isn't it? That's quite a magic number. So we're going to add our magic number to both sides. This is going to need some adjustment, isn't it? I'm going to leave some room to do that. 9/64. Okay, what do I have to multiply times 4 to get 64? Well, I know it's going to be 10. That'll be 40, and then that leaves me 24. It's going to be 16. I'm going to have to top and bottom it in order to get that. 16 times 3 is 48. Okay, so I'm going to be adding 48 to 9. When I get to that, let's do it now. 48 plus 9 is 57, and then my denominator is 64. Oh, it's kind of ugly, isn't it? But that's fine, we'll deal with it. I notice the bottom is a perfect square. Remember, that will always be true. Even on the right side, with that creepy fraction, your bottom's going to be a perfect square. So that's happy. On this side, I want to write my other, which I created with my magic number. And I remember that if I look inside my parentheses, that gives me the number that belongs here. It's minus. I forgot to write that. So it'll be minus 3/8. Does that make sense? See, if I multiply it, that's wrong. It's positive 3/4. And this is positive 3/8. Because If I multiply this times itself, I get 9 over 64. If I add it, I get 3/8 plus 3/8, that's 6/8, and that simplifies to 3/4. And so that worked out beautifully. That was creepy, but I can deal with it. Now we take the square root of both sides. X plus 3 over 8 equals plus or minus. Now I'm going to try and fix these. I can't fix the top. 57 is a prime number. It's not going to reduce. But the bottom, square root of 64, that's 8. Hallelujah. That's cute. Now for my final step, I subtract that and I get x equals minus 3/8 plus or minus square root of 57 over 8. Wow. You feel smart? You should, because I know you understood that. And it looks really complicated and hard. Again, the only thing we did differently is we divided away that coefficient in the beginning. And it created drama, because we had to do all of that dividing. But it didn't change the rest of the process. It did give us a profoundly ugly answer, but that's okay. We can handle that. And there's just one more problem in this lesson. Another one that we shall run through, example 58.2. Here is our quadratic, 5x squared minus x minus 2 equals 0. John's being really nice and he's giving us a perfectly clean quadratic equation. Nothing's out of order, nothing's on the wrong side. He's being nice about it. But there's that coefficient that is not equal to 1. So our first step is we have to divide everything. And obviously the reason we're dividing by 5 is we want that to cancel out. And we want to get back to having a coefficient of 1, which we can properly ignore. So that cancels and we get x squared minus. Now I'm going to write this as 1/5 x. I could write it as x over 5, but it's just a little bit neater and cleaner mentally if we keep that fraction separate from the x. Minus 2/5 equals 0. I always divide this side. I divide it by 5 even though I know it's going to end up as 0. But I want to remind myself that I have treated every single term in the equation equally. I do not want Hannah Cranny coming down on me, you guys. She would not appreciate that. So I divide it by 5 even though it's kind of predictable what I'm going to end up with, but that's okay. All right, kick him to the curb. X squared minus 1/5 x equals 2 over 5. Now I'm ready to magic number. Minus 1 over 5 times 1/2, which is the same as dividing by 2, but when I have a fraction it works way better. Squared it. This becomes negative 1/10 squared. That's the number I'm going to want later. This becomes plus 1 over 100. The magic number is 1 over 100. That seems magical. I can get behind that. I'm going to add 1 over 100 here, but I need to fix this by multiplying it by 20 over 20. And so this becomes 40 over 100. So this becomes 41 over 100. There's our perfect square on the bottom again. So that's happiness. And now we just need to fix this side. Write our perfect square. This tells me what I need to go in my perfect square, so it's x minus 1 over 10. Let's check it. It should multiply by itself to get this. That would be positive 1 over 100, check. And then if I add them, excuse me, minus 1 over 10, minus 1 over 10 would be minus 2 over 10, which simplifies to minus 1 over 5. Yay. Okay, square root, x minus 1 over 10 equals plus or minus, that's going to stay the same. That can jump out as a square root. All right, and final step, we add 1/10 to both sides. X equals 1/10 plus or minus the square root of 41 over 10. Yay, that's the right answer. I want to say one thing about presentation. Some might argue that we could write the answer like this. Right? The denominators match, oh, plus or minus. The denominators match, so we could squish that together into one fraction and write it like this. I wouldn't take off points if you presented it this way on a test, but I like this better. I like to see these as two separate fractions because we want to, why do we want to do that? I'm not sure exactly why, you guys, but this is the mathematically preferred presentation of the answer. I'll tell you why. It has to do with complex numbers and imaginary numbers. When we get to that stage where our answers include those components, then I'll come back and explain to you why this presentation is better. But for now, just keep those little fractions separate. Resist the temptation to mush them together. That is all there is to lesson 58. My favorite kind of lesson. Meaty, interesting, short, and sweet to the point. See you at lesson 59.